Hey guys, so we're gonna do lesson 10.2 or 10.1, sorry, today, and it's properties of dilation. So this is another transformation, except it's a little bit different than the previous transformations. And if you haven't already seen by the pictures here, you can probably tell it's different because we're changing size. Now, if you read all this up here, that's what it talks about. We're changing the size, but not the shape. That's mentioned right here. So whether it's this rocket that got smaller to larger or our triangles here, we're just changing that size. And the size, changing of size from big to small or small to big, is called a dilation. And it says that every dilation has a fixed point called the center of dilation. And this is located, where the lines connecting corresponding figures intersect. So really, this is a great example. I have the smaller triangle and the larger triangle. And remember, how do I tell which one's my pre-image and my final image? Look for those little prime symbols. So this blue is what I started with, and this green is what I ended up with. And so we went from small to big. This is that dilation. And it's saying where these, basically, if you see where these vertices, right, are lining up for all of them, they all lead to one center, and that is the center of dilation. And that's kind of what it tells you right here. So I am showing you the answers because I know, like in class, and maybe you don't have a ruler with you, if you were to measure all of these, a lot of times we're off by just a little bit. So I want you to at least get the correct measurements. And really what they're wanting you to see here, guys, is if I measure CR prime, so from the center to R prime, what did I get? I got 5 centimeters. And if I measured from point C, or my center, to R, what would I get? I would get 2.5. And then these items here that look like fractions, those are ratios. And it's wanting you to find the ratio. So if I divide 5 by 2.5, what is my ratio? My ratio is 2. And the same thing, C to S prime, and then C to S, I would get these two numbers. 4 divided by 2 for my ratio is 2. CT to CT of the pre-image, so CT to the actual image is 6, and C to T of the pre-image is 3. And 6 divided by 3 would be 2. So you can see those are the measurements you should have gotten. And what does that mean? And so when we say write a conjuncture, really, guys, when we're talking about a conjuncture, it means just a conclusion. What can you conclude based on this data? Well, I can conclude that the ratios are all equal to 2, because are they not? That's what you found. And if those ratios are all equal, that means that the distances are proportional. And then it wants you to, again, do the same thing, except instead of finding the distance from our center, you're going to measure the lengths of the sides. So we have R to S, so from here to here, of prime, and then of your pre-image, R to S. And then again, we're finding all of those ratios. So again, here are the correct answers, because like I said, I know sometimes in class we were off just by a little bit, so I want you to have the correct measurements. But what you should see again is that I should find that all of these ratios are the same. And so again, for D, we're going to write a conjuncture, or guys, a conclusion. What can we conclude about those ratios? Well, we can conclude that all the ratios equal 2, which means all of these side lengths are proportional. So if all of the side lengths are proportional, we should be able to answer E. The angles should also be what? And if you measured all of them, you would find that all of the angles are congruent. Because again, we are making the shape itself bigger or smaller, but we're not actually changing the shape. So the angles, the lengths of the sides should be proportional, or should be, congruent in some way with that. The angles should be congruent, but the sides should be proportional. All right, that's really all we're going to mess with over here. Let's go look at page 316. So exploring dilations on a coordinate plane here. So again, you can see all the answers, but let's see, how are we getting these answers, and what are they actually having you do? So it says complete the table and record x and y coordinates of the points on the two figures, and then you need to find the ratios. So we're looking at how the coordinates on these figures and the coordinates on the plane, how are they affected by a dilation? So again here, you can tell blue is my pre-image and green is the actual image. So we're shrinking this instead of, or reducing, I guess you could say also. So let's look first, let's get our actual vertex. So vertex, or guys, they're just talking about your coordinates. That's another name for X and Y of your actual image here. So A, you should have found it's at 1 and 2.5. I know it's kind of tricky, but A prime here, it's about in between that 2 and 3, so 2.5. B prime is at 2, 1. C prime is 2, 2. And D prime is -2, -2. Okay, so once you have that, go ahead and you're going to find all of the coordinates for the pre-image or the blue. Okay, so here are those. Now, this part, I will admit, seemed a little confusing. Well, what are you supposed to do? It says these ratios of x coordinates, and then it has all these primes, and it's giving you an example, but how on earth are they getting this? So you're not adding or multiplying a prime, b prime, c prime, d prime, and then dividing it by this. No, 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 no. You're just going to look at your two x's for a prime. So I went ahead and kind of wrote it out here, but I'm looking at a prime to a. So a prime, my x was 1, because these are x coordinates, right, the ratio. So -1 to 2. So I'm going to set up these ratios. -1 to 2, if I divide them, I get 0.5. And that's how they're getting 0.5 here. I can do the same for b prime. 2 divided by b, which is 4, would give me 0.5. Same for c prime. C, or prime divided by, or 2, sorry, divided by c, which is 4, would give me 0.5 again, and then the same for d prime. So that's how they're getting 0.5 for the ratio. You're going to do the same for y. So 2.5 divided by 5, 0.5. 1 divided by 2, 0.5, and so on. You get the idea. So I know it looks confusing because they're listing all these. Really, they're just wanting you to get a ratio between your your primes and your, or should I say your image and your pre-image, okay? And then B says, write a conjuncture of, or about the ratios of the coordinates of the dilation image to the coordinates of the original figure. So what do we see about the ratios? What conclusion can you come up with those ratios? Well, your answer here, the ratios all equal 0.5, and we can see that. And when you did your math, you should have found they're all 0.5 or half. And so all of those ratios are proportions, which tells us that these images are proportional. So we did change the size, but not the shape itself. All right, moving on here. So let's look at this example or of a scale factor here. So finding a scale factor. So if you've seen in the last two activities, a dilation can produce either a larger image, and you would call that an enlargement, or a smaller figure, which would be a reduction. So a scale factor describes how much the figure is enlarged or reduced. The scale factor is the ratio of a length of the image to the corresponding length of the on the original figure. Guys, you already found scale factor. The scale factor here, what's the ratio? 2. Here, you found the ratio. What's the scale factor between A on your image to your pre-image? It was 0.5. So those are scale factors. They just didn't tell you you were finding scale factor, or the scale factor. So, and that's really what it tells you right here. You had already found them. So how do you find it if they're giving you these images here? And that's kind of what they're doing. It says the art supply store sells several sizes of drawing triangles. All are dilations of a single basic triangle. The basic triangle and one of its dilations are shown on the grid. For the scale, or find the scale factor of the dilation. Well, this, guys, it tells you, and they make it really easy. They just want you to find the lengths of each side, which it's on a grid. You don't even have to do a whole lot of math. You can count. So they want you to do for AC, for this triangle to this triangle. What did you find? So AC, we can compare this side. A to C is 1, 2. So that's where we're getting 2. And AC, or A prime to C prime, is 1, 2, 3, 4. So 4. And they did the same thing for C to B and C to B here. And could I do A to B and A to B here? Yes, but guess what? I'm going to find that they're the exact same. So then I would divide these. I would divide the prime by the, the image by the pre-image, and I should get 2. Again, you want to make sure you're dividing the image by the pre-image, or the primes by the, regular letters there. All right, so I should find here that your scale factor of the dilation is 2. So if I go up here, and let me turn my paper over here, if we were to find, what is my scale factor for number 5 here? Again, I have 2 images. You can pick 2 sides just to check yourself. So I went ahead and I chose, D prime and G prime, and I'm going to divide that by DG, okay? Because that's the ratio I'm looking at. So D prime to G prime is 2, divided by regular D to G, which I found was 4. 2 divided by 4 is 0.5, okay? And I can check myself just to make sure my ratio is proportional. We can do the same, here, with G prime and F. So, 1, 2, 3. So G prime and F prime is 3. And I'm going to divide that by, let's do up here, G to F. So 1, 2, 3, 4, 5, 6. So GF has a length of 6. 3 divided by 6 is 0.5. So what is my scale factor? 0.5, or half. Okay. And in this case, would you say you were enlarging or reducing? How can I tell? Well, I need to tell which one of these is my pre-image. Well, the pre-image is not the one with the prime. So I started out bigger and I got smaller. So in this case, it would be a reduction. All right, guys, that is the end of the video. Hopefully that helps. If you have any questions, like usual, let me know. Bye.